This is a quick demo of how to do a bracketing plot using DynoChem Design Space exploration tools and Excel pivot tables. I'm going to first do an exploration where we vary principally two factors, which are reagent and temperature. So those are the focus of the exploration. But simultaneously we are concerned about common cause or other variability in two other factors, the volume of solvent and the amount of substrate, which could be a product from a previous step. So for reagent and temperature we'll do 9 levels of each over a typical range of interest, and then for the volume we'll do 3 levels and we'll put a 10% range as an example of common cause variability, and for substrate we will do 3 levels with again a 10% range. So that's a total of 729 simulations. Press the run button to have DynoChem set up those scenarios and run them. As usual, the scenarios are added to the Scenarios tab in the Excel workbook. And then all the scenarios are run in the background behind Excel. Then on completion we get a Results tab with all the inputs and outputs. So that's all very normal. Now to make a pivot table and a pivot chart that allows us to do a bracketing plot, we can again proceed as normal, select all of the responses and all of the inputs. Say we'd like to plot results Excel pivot chart, and that creates a pivot chart which actually shows the sum of all the impurity results by default. So first I'm going to just get it to look at the factors of interest on the horizontal axes. So I want reagent and temperature. Just going to maximize the Excel window for a moment. So I want impurity in the values cell, reagent on the axis fields, and temperature in the legend fields. So now I have a plot of the sum of all the impurity values, which is basically 9 simulations at each grid point in this plot. And usually I'm not too interested in the sum over 9 experiments, so here I can change the displayed attribute from sum to average, and average will show me the average of those 9 runs, so the ones in which we have common cause variation of volume and substrate amount. This is the average result. So you can see a peak in the top right hand corner of almost 1 gram of impurity. I can use the same control to show instead the maximum. So out of the 9 simulations at each grid point, reagent and temperature, the maximum impurity is a little bit above 1 gram, so that will give me an upper limit taking into account the common cause variation of volume and substrate. And similarly I can go for a minimum from the pivot chart controls, and it will show me a max now of 0.8 grams impurity. So this is a way for me to get 3 separate graphs of the average and then the maximum and the minimum, taking into account the simultaneous variation of the factors that we're not plotting, volume and substrate. Now also here you can go to the pivot table, which is created automatically when you make the pivot chart, and you can simply copy the cells in that table to make another pivot table, and then to make another pivot table. So right now they're all identical, but I can then go to the top table and say, yeah, I want to see the minimum of the impurity on that table. And then I can go to the second table and say I want to see the average. So change the value field settings. So now I have average in the middle table, and then I can go to the lower table and say I want maximum. So now I have on a single sheet the minimum, the average, and the maximum. And obviously I could copy and paste these somewhere else for further plotting or analysis. Quickly though, here in Excel I can make a kind of a dashboard type plot. So I'm going to use conditional formatting and color scales, where blue is low impurity and red is high impurity. And I can apply that same styling to each table. To give something that is more like a contour plot of the results. So that's one option. What I would like to do is to hardwire the settings for the numbers so I get comparable coloration amongst the three tables. So I can do this by editing the settings and saying I want a minimum of 0 and a maximum of some number. In this case 2 grams is a good maximum. So that gives me obviously a less red region for the minimum contour plot. And again I can edit the rules for the average. Lowest value defaults to 0. Highest value needs to be a number, and the number is 2. And then say OK. And then I can go to the contour plot for the maximum and do the same thing. Lowest value 0. Highest value 2. And then say OK. So this gives me now more of a kind of a heat map with consistent coloration between the three. In fact, 2 is too big, isn't it? I need to go for something like 1.2. So that gives me a more clearly defined coloration between the minimum impurity level I can expect and the maximum. But I guess the main thing is that we have the numbers in a table now, and we can do some further work with those numbers, do some further plotting with them. And all of that can be accomplished just by generating the pivot chart and then doing a little bit of work with the tables afterwards.